Hey everyone, so I cut off the last video. Please watch it. I apologize that I did cut it off, but it kind of explained where all these, like the different isotopes come from. Make sure to watch the other videos. You can also look up things online. I'll try to share a reading um, thing with this so that you can read and go through it. But I'm going to go through the behind the mathematics of why this occurs. So, like sodium, sodium is 11. Atomic number is 11. Its symbol is Na. We'll discuss why it's Na when it says it's S. And then they have this number down at the bottom that's 22.9990. Might have thrown an actual accident, an additional 9 in there. But and then we have magnesium, which is 24.305. So why is that? I'm going to go back to what I had previously. So a mass number is the mass of a single atom. We did this in the previous video that I'll post, but it's just kind of going over some definitions so you'll know how that goes. Okay, so one atom, like one single atom of oxygen, is just depends on the situation. Remember, the mass is protons plus neutrons, so it's what's in the nucleus. So if we're doing nitrogen, it will have 7 protons. Sometimes it has 8, so the mass would be 18. Excuse me, 15. Sometimes it has 7. Um, so the mass would be 14. And that just depends on the number of neutrons because nitrogen is nitrogen because there is 7 protons. But if you see there's this 14.007, that is not indicative of a single atom. That is indicative of the average of the isotopes of a stable substance. Okay? Stable atom. So you can't have nitrogen 15 because it's not stable and it degrades into another atom. So that's for another topic. Okay. Actually, that's very, very important in the carbon and the nitrogen cycle because majority of our atmosphere is made out of this stable gas, nitrogen. We don't want a bunch of carbon dioxide in there because it heats it up. And we don't want a whole bunch of oxygen in there because it heats it up. And we also don't want, or excuse me, it's flammable. It will combust if we have any type of fire. It will go just boom. And then if we had a whole bunch of water in there, it's also a greenhouse gas. It will heat the earth up and trap the heat in. Okay, so what we're trying to find is this average atomic mass. It's the average, the amount of each type of stable, the average amount of each type of stable isotope for a given substance. So carbon has 3, nitrogen has, I think, 2. Okay, so we're going to find out in a general natural trend what occurs on that. Okay, all right. And so nitrogens would be 13 and I think 14. Excuse me, I think it's 13 and it's 15, 14 and 15. So from the previous videos, and that's probably where it is, it's the most common natural isotope. But here I'm going to be doing the math behind it. Okay, I'm going to go pause. Okay, I pulled this up. So you guys should probably would have had this on your notes, but the things you need to find in order to find that decimal is there's 3 things. So one, you need to find the total amount of the different isotopes. Okay, So when we go through that, you'll find out, and I'm going to have you guys make a chart. That's the easiest way to do this, is you just make a chart on how many um, types of isotopes that we're talking about. Number two would be the natural abundance, meaning the percentage, aka the percentage. The natural abundance of each type of isotope. Okay. And the third thing is we need to have the mass of each type of isotope. Okay. So we'll come back. I'll repeat these, but say that you had a test score and you have 70% of your grade is test, 20% is your quizzes, and then 10% is your grade. So this is a real world application. And again, I tell in class, like when you're milking a cow in Argentina and your boss wants you, while your boss is the farmer, and he says, I want you to find the average atomic mass of carbon. Well, now you'll know how to do that. However, in real life, it probably wouldn't happen, but we use these real life situations. We use this in real life. So I'm providing you the tools to be able to be like, okay, if I have this amount in this chunk, then I could go use this amount in this chunk and I can figure out the overall thing. So if I look at these statistics here and I have 80, I got a test score of 80, 100, and 100 for my homework and quiz. I can roughly guess, most kids have said about 84. Some have said 88. I had one kiddo say 75 and they go, whoop, whoa, 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 that's not right. So if we look at this, it's going to correlate very easily. And I'm going to go through this quickly so I can do an example. Okay. So you have the total amount of the different isotopes, the abundance, and the mass of each type of isotope. Okay, so the abundance would be the decimal, but don't forget, convert your percentage to a decimal. And the magic number is 100. So you move the decimal 2 places. 2 zeros, 2 places. So basically what they're going to do on this one, and this is not how I do it, we're going to turn that 70% into a 7%. But with that, we got an 80. And I really recommend that you guys, I'm going to just convert. You could take, I can show you 20 divided by 100. That's that. And so that's the same thing as 0.2. I know this isn't going to look right. And then that would be 100. Excuse me. 100. And then this would be 0.1 times 100. And if I were to put that into my calculator, make sure you press equal. I would get a regular calculator, not your phone. And you have to just make sure you multiply, press plus or press equal, and then do the next calculations and the next calculations, the next calculations. And you should end up with 86. Okay? So what I do, I'm going to go ahead and pause it here. Okay, so I made a chart and you're going to see what this means here. So I always just make a chart. It's a lot easier that way. You'll see even above, you could do it as up there as like that. But I think just having the chart makes it a lot easier. And I've had a really, really good success on that. Also, Also, remember that the unit is AMU, atomic mass unit. I'm not going to get into what that is, but I'm very particular on units so that you can understand what you are talking about. If you write 13, I don't know what you're talking about. 13 candles, 13 pajamas, all of that. So here's the problem set. I'll try to get through 2. If it stops at 15, I won't be able to. So calculate the mass of chlorine with 2 common isotopes that have the mass of 35 with an abundance of 75% and 37 AMUs and 25% abundance. Okay, so I just made this chart. Pretty simple, pretty easy. Recommend doing this by hand, not typing, a lot easier. So we're going to have 2 isotopes, and I made 2 different columns there, excuse me, rows there. So we have chlorine, and that is 35. Or I'll just put 37. It does not matter. And we have chlorine 35. Okay. Their abundance, I'm going to go ahead and move this over. This one is 37. Oh, excuse me. I'll switch that around. 35 and 37. It doesn't matter. I put it in order that you read it. Okay, so the abundance is 75%, 75.00%. Very good job that this person did, that they added those 2 percentages. And then we have 25.00%, or those 2 decimals. So I'm going to convert it. Each of these, once I'm converting it, this is a step you can skip. I had students previously that did not, because they just wanted to feel comfortable knowing what they were doing. So, because we're made a percentage now, this could be a collection of 400 tons of chlorine. This could be a collection of just a few milliliters of chlorine. So that's why we deal with percentages, because it's not about the amount we have, it's just the substance within each of those. And so when we had the bunny rabbits, that's what they were. I might have to have a different video concerning this. I'm just running out of time. So this would be 0.75, and this would be equals 0.25. The mass on this one is 35. The mass on this one is 37. I'm going to multiply that 0.75 times 35, and then 0.25, and technically it's 0, but right now we're okay. 37, and if we're not going to worry about sig figs, I'm going to pause and get my calculator. Okay, so I did my calculations here, and these are actually AMUs. Okay, so just like our test up here, is that each of these you had to multiply, and then you had to add them up in between. So here we have to add them up. What's 25 plus 25? That's 0.5. 9 plus 26 is going to be 35 and I'm not carrying anything over, AMUs. And that seems about right, that it's going to be closer to the 35 because of 75% than the 37. And that seems very logical. You have to have it in between 35 and 37 in this case, because of the percentage, or just our 2 masses. All right, I'm going to go ahead and let you guys go. I've got about 20 seconds. If you have any questions, let me know. Bye-bye.